Hello, and welcome to Patch Math, where today we are going to patch your math knowledge on the ERB exam. In this video, we will be looking at the quantitative reasoning section. If we open this up, you can find this practice exam at erblearn.org. That is erblearn.org. If we open this up, you'll see that there are two different mathematics sections. And so we're focusing on the quantitative reasoning today because it likes to ask traditional math problems in a non-traditional way. And you'll see what I mean in a moment. Let's go ahead and get started. So looking here at question 21, you'll see that the quantitative reasoning has a format. And it actually confused me a lot. It was a little bit embarrassing during a lesson. They had used A in 3 different scenarios. Now here they're using 2 different A's. We have the A here from these choices, but then we also have the A here in the choices. They're doing it with B as well. But there was an example where there was an A up here in the problem as well. And there was the A, B choices here, and there was the A, B, C choices here. So it was used, I was really confused until I realized every single question on the quantitative reasoning section is formatted with this A option and B option or scenarios. And then once you have those scenarios understood, you are to compare those scenarios and select from this A, B, C, or D, which of those scenarios is true. So now that we've got the pattern down for quantitative reasoning, you'll see what I mean when I say they ask traditional math questions in a non-traditional way. Looking here, they give you a square with a side length of 2 inches, and it says the length of each side of the square above is doubled to make a new square. So we're going to do that real quick. So you'll see I put a new square to the right of this sheet. Double the side length is 2 times 2, which is 4. Double 2 is 4. And this is a square. And since I sketched it, I'm going to use these little tick marks, which denote all sides with 1 tick mark equal 4 inches. That is important here. We are dealing with inches. So the length of each side of the square above is doubled to make a new square, and this is our new square. We have scenario A, which says the number of inches in the perimeter. Keyword there, perimeter. So if we are going to find the perimeter of our new square, we can always do it manually by the definition of perimeter, which is simply start at one point, let's say here at this corner, and start traveling. 4 inches. Keep traveling. 4 more inches. That makes 8 inches. 4 more inches. That makes 12 inches. And 4 more inches. That makes 16 inches total. And we can define it as how many inches does it take to travel around the square completely. Now, some of you all like a formula, and that's perfectly fine as well. Let me clean up my image for a moment. All right, and so perimeter of a square, specifically of a square, is defined as 4 times the side length. Moving on, let's look at scenario B. Scenario B says the number of square inches, that is important, units do change in this scenario, square inches in the area of the new square. The area of a square can informally be described as the amount of space covered between the side lengths. So I'm obviously not shading well between the lines, but I like to use some analogies. If we're dealing with a field, all right, like a farming field, and let's say you want to fence that farm. Like you want to put fence around a field. And so your fence, the amount of fence that you'll need in inches, that is your perimeter, the amount it takes to outline the field. Your area is going to be the amount of grass on the inside of that fence. All right, it is going to be the area, the amount of square footage, or in this case, square inches that well, if it's inches, that would be a very tiny creature, but let's say square miles would be more humane for a field. And then the square miles would be how much area the farm animals have to graze there. So in this situation, the area of the square is going to be amount of area that is covered on the inside of those side lengths. So I like to go straight formula on this one. It's going to be side length. So S side length squared. All right. If you are dealing with a rectangle, it's length times width, and it's still length times width for a square, but length and width happen to be the same thing, so side length squared there. We have a side length of 4. And notice your inches are also, your units are going to get squared here. So that is going to be 4 squared, which is equal to 16. And that is 16 square inches. All right, so now we have to be careful here. I went ahead and when I was first taking a glance at this, I was like, oh, automatically A and B can't be equal because one's inches and one's square inches. The units are not the same. But we have to be careful. If we look here, it says the number of inches and the number of square inches. So it's the number in front of our units there. And because it is asking for number only, all right, number only, and not comparing both answers as a whole, so including units, not including those in this comparison. We are looking at just the 16s there. And on this problem, you'll see that A and B are equal. We have a 16 and a 16. A and B, A and B are equal. Moving on. In the next video, we will cover this quantitative reasoning problem. Thank you so much for your time.